So today we are going to do the next chapter in our syllabus, which is fuel. So we are going to do the next chapter today, which is fuel. What do you know about fuel, guys? Sarvesh will tell me what is fuel and why is it necessary. Kunal will tell me where is fuel stored in an aircraft, how is fuel utilized in our aircraft, and fuel is required for what all things in our aircraft. Krish will tell me, no, Krish hasn't done tech gen, right? So Asmit and Subal, you guys will tell me fuel quantity measurement किस हिसाब से होती है, okay? And Krish will tell me what are the things that you need to take or think about when you need to do refueling. Okay. So Sarvesh, we are gonna start with your what is refueling? What is fuel?
फ्यूल कोई भी सब्सटेंस जैसे सॉलिड लिक्विड और गैस फॉर्म में जो एनर्जी प्रोवाइड कर एनर्जी जनरेट करने में हेल्प करता है विद इंजन्स
Absolutely correct. With the help of process of combustion.
कम्बशन कम्बशन
Okay. So what is fuel? Fuel is anything that has chemical energy stored in it. When you undergo a certain process that like combustion, we can convert that chemical energy, produce it into heat energy, and thereafter derive energy out of it. Okay. Where is it stored in an aircraft? Wings. What is it used to burn and produce thrust? Okay, Kunal, let's go to your question.
भाई मेरा क्वेश्चन तो यही था ना कि कहाँ स्टोर होता है
Khan store
स्टोर
in
इन
the
द
wings
विंग्स
and
विंग्स में एंड इट सप्लाइज मैकेनिकल पावर टू द कंट्रोल्स
what do you mean
एंड
mechanical power?
सिस्टम्स
So, absolutely, listen. So fuel is stored in the wings. Fuel is stored in the center tanks. These are the two places where fuel is stored. Apart from this, fuel is distributed and it is recirculated. Okay, this next question to you was, what else is fuel used for? Fuel is used to drive a number of valves inside the engine. Okay, fuel is used to drive a number of valves inside the engine. Have I made myself clear? Okay, using some through something known as a HMU, a hydromechanical unit. For example, the valves which are related to or the actuators which are related to active clearance control of the turbine or the rotor active clearance control. Okay, so the fuel not only does it supply to the engine for the purpose of production of thrust, but it is also supplied to various different actuators inside the engine. Also, fuel is used to cool down the IDG oil and the engine oil. Engine oil is not cooled by air, it is cooled by the cold fuel. Cold fuel needs to be heated, hot oil needs to be cooled. So you pass it through an heat exchanger where the colder element is fuel and the warmer or the hotter element is engine oil or the IDG oil. The fuel system. Okay. Subal, what was your question?
how to measure the fuel quantity in the tanks.
Yes.
So for that reason, yeah, we have the valves basically, which transfer valves, which uses mostly to transfer the fuel according to the sensors present in the fuel tanks.
That you're telling me about the transfer system. Tell me about the fuel measurement system. Quantity measurement.
फ्यूल मेजरिंग वो ही है हमारा जो टैंक में जो मेजरिंग सेंसर्स होते होंगे एक सर्टेन लेवल तक अगर उसके नीचे चला जाए इंडिकेट्स अकॉर्डिंगली
Okay, so तो कोई भी बता देगा. This is a class 1 guy
So
will also tell me. How is it measured?
there is a fuel quantity indication system.
Okay. How does it work?
तो it is a computer and it measures in mass. So हमें kilograms
How
में
does
देखो.
it measure it in mass? नहीं पता. Okay. So we're gonna study कि यार वो कैसे करता है. Don't worry. Apart from that, Krish, what are the precautions that we need to take during refueling?
uh,
The reason why
you
I'm
have to
asking
be a
you this is you have done your flying from New Zealand, and all of the people who have done the flying from outside India, they might have had to refuel the aircrafts on their own.
You have to be a certain distance away from a building. You have to be a certain distance away from, and that you have to be a certain distance. There can be no smoking, of course, or
No source of ignition whatsoever. No source of
hmm,
ignition whatsoever.
no source of ignition. And other than the major precautions are just you have to be an X distance away from building, from any people from another aircraft. That's all I remember.
Okay. Do you remember something about bonding? Okay. So let's start with the chapter of fuel. That was some brief introduction so that I could, really get around ki what is the scope of the class. यार उनका कितना पढ़ाई हो चुका है. So we are going to start with fuel. This is ATA chapter 28, fuel. What are the two fuels that are used in an aircraft? In our aircraft, which is the Airbus 320, that is the Jet A and the Jet A1 fuel. Jet A and the Jet A1 fuel. Okay. Jet A1 is used all around the world. Jet A is from the United States, and Jet B is a fuel which is primarily used in the colder countries, the Baltic region, and the Russian and the Canadian region. Okay, that is Jet B, also known as AVTAG, turbine gasoline. So it's a mixture of gasoline and it's a mixture of kerosene. Now, piston engine fuels were gasoline-based fuels. Jet engine or turbine engine fuels are kerosene-based fuels. What is the difference between them? Kerosene doesn't evaporate, or it's not as volatile as gasoline is. The specific gravity of any kerosene based fuel like Jet A or Jet A1 is decimal 8. What does this particular value mean? This means that if this much amount of water weighs 100 units, this much amount of fuel will weigh 80 units. So basically it is the density of the fuel in comparison to the density of water. That is known as relative density. That is known as relative density. Okay, so Jet A or Jet A1 has a specific gravity or relative density of 0 decimal 8. Okay, कोई doubt? No doubts. Now let's talk about the system of the fuel. The fuel system stores the fuel in the tanks. How many tanks do we have? We have three tanks. You have the wing tanks, which is the inner and outer, and then you have the wing center tanks. Correction, not the wing center tanks. You have tanks on the wing, and you have tanks inside the fuselage of the aircraft. So I'll call it 1, 2, and 3. MSN to MSN, these tanks differ slightly. We will talk about the differences soon. The fuel system is also responsible for refueling the aircraft. This aircraft can be refueled completely automatically without any input from the refueling staff as well. It also supplies the fuel. It also supplies the fuel, and it also circulates the fuel for heat. And it also circulates the fuel for heat. What do you mean by supplying the fuel? Supplying the fuel to the engines and recirculating for cooling of the IDG oil and the engine. Any doubts? All of these functions are done by the fuel system. Not only this, it also indicates the amount of fuel that we have, which is not written over here. It transfers the fuel from the center tank to the wing tanks. Now this is another function. It's an if installed function. You'll realize that fuel transferring only happens in a few MSNs and not in the other MSNs. I'll show you MSN to MSN based difference. And it supplies the fuel in such a way that it keeps the fuel in the outer tank. Why do we want to keep the fuel in the outer tank? So as to prevent wing surface flutter. This is an aircraft. If I have weight on the wings, if I have weight on the wings here, do you think this will bend? Do you think this will bend? No, no. That's the funda that he's coming. Open FCOM, go to 28, chapter 28. Go to chapter number 28 in your outlines. Under 28, you see two portions, 2810 and 2820. 2810 is description, 2820 is controls and indicators. Under 2810, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 different subsystems. You have 9 different subsystems. Okay? Is that Krish? Sarvesh, is that Krish behind it? So, have you all located the FCOM and its different subsections? So, you can see there are a total of 9 subsystems inside the fuel system. So, it's a little vast than we can actually imagine. Let's go to general and let us understand कि यार ये fuel करता क्या. We have already understood कि यार ये fuel system करता क्या. So, 28.10 is completed. We will go to the next DU, which is 28.10.20, which talks about the tanks, and the components. Now, if you open the FCOM, you will see a number of different tanks. You will see a number of different tanks. Primarily, there are two layouts. Primarily, there are two layouts. This is the first layout. This is the second layout. Let's have a look. The first is this one, which is the center tank. This is housed inside the fuselage of aircraft. This is housed inside the fuselage of aircraft. Okay. Also, as you can see, this is mounted below the wings. This is बहुत नीचे में है ये. It's a little down. So the fuel which is stored in the wings is at a higher elevation than the center tanks. The engines are somewhere over here. So the fuel can actually be gravity fed directly from the wings to the engines. However, fuel from the center tanks cannot be fed to the engines directly with the help of gravity. At any given point of time when you're doing gravity fuel feeding, this fuel inside the center tank is unavailable. Clear? Also, the fuel will not naturally not flow from the center tank to the wing tank. You need to have a transfer system if it has to go from here to here. However, due to different layouts, due to different layouts, पहला लेआउट ये, पहला दूसरा लेआउट ये, अलग अलग लेआउट्स में अलग अलग फ्यूल उठाने के सिस्टम. वी आर गोना discuss about fuel recirculation and the architecture of it over here once we reach. Okay, so the first one is one center tank inside the fuselage of your aircraft, and these two are in the wings. These two are in the wings. In each of the wings, you have an inner tank, which is the bigger one, and you have an outer tank, which is the smaller one. It's very really really small. Okay. Apart from that, you also have a vent tank, which is known as vent surge tank. Okay. This caters for expansion. This caters for expansion of the fuel. And maybe if you're in a maneuver, the fuel is sloshed around. तो वो कहीं पे भी जाएगा यहाँ पे आ जाएगा. If it tries to actually go outboard, वो इधर आ जाएगा. Open the FCOM, go to the tanks section. Read the third line. There is a vent surge tank. Okay, outboard of the outer tank in each one. So now, what is the capacity of this tank? 2%. 2%. It is there for expansion, right? So the capacity is 2%. Approximately, the aircraft can hold about 90 tons of fuel. How much? 19 tons of fuel. 2% of 19 tons is how much? 1, 2, and you multiply by 2. 380, 380. No doubts. So this is the wing tank, and ये तुम्हारा क्यों है? अब ये अच्छा देखो, each wing tank नहीं, this इसका capacity is 190, इसका capacity is 190, so together मिला के 2%. So each vent tank has a 1% capacity. Why is there? So as to take care of a 2 degrees Celsius increase in temperature. Any doubt so far? इन सबके नीचे ना, ये हर विंग की जो टैंक है ना, इन सबके नीचे, विंग के नीचे there is an over pressure burst disk. So her wing tank, read the last line please. There is an overpressure protector in each vent, outer and inner tank, and in between the center tank and the left tank. Achha, have a look. I'm going to show you an image. Now, have a look. ये आपके विंग के नीचे, you can see this cross mark symbol. So this is the overpressure protector. If in case, see the entire fuel system, the fuel tank, it's a sealed chamber. It is a sealed chamber. अब तुमने अगर उसको full on top up कर दिया और actually fuel expand किया, if it actually builds beyond a certain pressure, this particular disc will get burst and the fuel will come out. So in the external walk around also, you have to check that ये burst नहीं हुआ, that ये burst नहीं हुआ. This is a part of your external walk around flows. Have I made myself clear? Great. So all in all, how many tanks do you have? You have 5 tanks. You have 5 tanks. एक सेंटर, दो इनर, दो आउटर. ठीक है, एक सेंटर, इनर इनर, outer outer. You can also have additional center tanks. What are additional center tanks? Inside the fuselage, inside the cargo compartment, what you can actually do is you can take some space out from the cargo compartment and you can place another fuel tank there. Each of those fuel tank has a capacity to give you 1 hour of flying time, about 2200 kilometers. So अगर तुमने एक ACT लगा दिया, तुम्हारी रेंज उतने 1 घंटे के इंड्योरेंस के हिसाब से बढ़ जाएगी. The endurance increases by 1 hour. Okay. How many ACTs can you keep? You can keep up to 3 ACTs. So now that Indigo has actually, brought in these newer XLRs. The XLRs क्या हैं? These are aircrafts which these with these ACTs, so they can basically go semi long haul all the way till Amsterdam. From Delhi, they can go to Amsterdam, Turkey, or maybe the Baltic regions on an A320 itself. That is the beauty of these aircrafts. Okay. आपके FCOMs में you will have another diagram under the fuel tank section.
Okay.
You'll have two diagrams. See the other diagram.
ठीक.
Okay.
Okay.
So in before you see the other diagram, now have a look. Now that my screen has again come up, you have 6 pumps. Now each of these pumps, there are 2 pumps here, there are 2 pumps here, there are 2 pumps here. 2 pumps are the center tank, 2 from either inner tank. Now, if these pumps stop working, can you still suck out fuel from here? Yes. यहाँ पर these pumps are known as booster pumps. These pumps are known as booster pumps. They supply the fuel to the engines. The engines also has 2 more pumps. It has a low pressure pump and it has a high pressure pump. It has a low pressure pump and it has a high pressure pump. Each of this sucks fuel from here. अब ये तो अच्छा है कि we are providing him with fuel. But if these pumps were to fail, will it be able to suck fuel? Yes, there are suction valves. ठीक है? Good. So that is about this entire system. These pumps are driven by what electricity? Are they engine driven pumps? No. They are driven by electricity and they are driven by alternating current. They are AC motors or pumps. Okay? This is one of the layouts. The other layout is you have a center tank, and instead of having an inner and outer tank separate, you have an entire wing tank. Clear? Beyond the wing tank, you have a vent tank. This is the second layout. I hope you all have these layouts in your FCOMs. For the purpose of your exam, which one will you study? This is what you have to study. That's why I've put up a star mark as well. Now, there are three tanks that had five tanks. So three tanks and up to three ACTs. You can have the one ACT, two ACT, or three ACTs as well. Now, look at the difference in architecture. This does not have six pumps. So it's either 5 6 or 3 4. So it's 3 4 5 6. This has four fuel pumps in each of the wing tanks. So wings have these pumps and they go to your engines. And they go to your engines. Now, likewise here. तो विंग का सेंटर टैंक विंग का टैंक डिप्लीट होते जाएगा द विंग विल कीप ऑन डिप्लीटिंग we are supposed to consume the center tank fuel first. Why? Because the fuel system keeps more fuel in the outer tanks. It preferably keeps fuel in the outer tank to prevent wing surface flutter. So we do not want these particular tanks to empty out so soon. So what you have some transfer pumps. They transfer the fuel from the center tanks all the way to the wing tanks. Okay, these were fuel pumps. They were giving fuel to the engine. Here, these are transfer pumps. Any doubts? Pakka? Great. Now, what is the quantity of these fuel tanks? What is the quantity of these fuel tanks? If you scroll further down, you will see a number of charts. You will see a number of charts. Please open your FCOM. You will see a table which has the words written usable fuel. Okay, I want all of you to go there. It looks really, really weird, है ना? देखने में बहुत complicated लगता है. I'll simplify it down for you. Look at the header. The header is usable fuel. So it firstly it does not account for unusable fuel. We have that in our head. Now let us look at the other columns. You have wing tank, center tank, ACT. So that is the capacity of the wing tank which is given. Now both the wing tanks combined. So that is why it is written two times this. Then you have center tank and then you have ACT. Each ACT can contain that much amount of fuel. Then on the right hand side you have a total column. So if you take a total without taking ACTs, you have that one. If you have up to one ACT, so basically he adds the ACT value by one time with two ACTs and so on and three ACTs and so forth. I hope I've made this very clear to you. Now, if you have an aircraft which has that kind of a system where you have wing tanks and center tanks, these are usually, they're on the A321s. These are usually on the A320s. A320s preferably have inner and outer tanks. Okay? Only the A321s have wing tanks and center tanks. Clear? No doubts? No? Chalo, good. Now let's go to the next particular same table but for the next MSOs. Here you will have a look where again you have outer tanks and you have inner tanks separately given times 2 and then you also have a center tank. Now look at the leftmost column. You have volume and you have weight. You will not never be asked for the volume, so you can disregard the first two rows. We will only be looked out for our weight, and that too we will be looked out for in 10 kgs. So out of this entire chart, you only have to study one row pertaining to your MSI. You have to study the weight corresponding to your unit for each of the tanks. So it's a very, very simple diagram. So it's a very simple diagram. Any doubts? Any doubts? No? Sure. Let's have a look at the capacities. Now these capacities, as you can see, the volume is there in liters and the weight is there in kgs. So they must have assumed. So they must have assumed something. They must have assumed a specific gravity of fuel. They have assumed decimal 785 specific gravity of fuel. Okay. The specific gravity is decimal 785. With this particular specific gravity, the total fuel capacity is measured in kgs is 19,000 kgs. How do we easily remember it? Can everyone remember with me the numbers 651? So the center tank can hold up to 6 tons. The inner tanks, sorry, the inner tanks can hold up to 5 tons. The outer tank can hold up to 1 ton. This is how I remember it. So 6 plus 5 is 11, plus 1 plus 1 is, sorry, 6 plus 5 is about 16, plus 1 18. This is a mnemonic for remembering. What are the actual capacities? The actual capacities is 6,500. So I remember it as 6. The inner tank capacity is 5,500 kgs. Here it is also 5,500 kgs. Okay, and the outer tank is 750 and 750 kgs respectively. Understood? So this, extra 500 plus extra 500 plus extra 500, all of these, इनका total करोगे तो 18 आ रहा है, but because you have extra 500 here and you have slight variation here as well, because of this the total actually comes out to be 19 tons. To be precise, 19.004. Okay, any doubts so far? Any doubts so far? No. Now for each center tank that you have, you can have up to 2.2 tons of extra fuel. So you add it accordingly. If you have two ACTs, you add 2.2 tons. If you have one more ACT, add 2.2 tons. If you have one more ACT, add 1.2 tons. 2.2 tons. Why exactly 2.2 tons? Because when you are in cruise, you consume 2,200 kgs of fuel in 1 hour. That's your fuel consumption for 1 hour. So each of these ACTs gives you 1 hour of flight time, essentially. That is exactly why it has been decided at this number. Any doubts so far? The other layout, for the purpose of exam, you will be studying this layout. For the other layout, we consider it the ACT as 2,300 or 2,200, something like that. But the capacities now are 666. So it's 6,500. The center tank is the same. The center tank is the same. No, absolutely any variations. But the wing tanks are 6 tons each. So 6 is 12 plus 6.5 is 18.5. This is the variation that we have. That has 19 tons. This has 18.5 tons. However, in the exam, these are very very similar values. Now you know कि around what will be measured. एग्जाम में अगर आएगा तो किस वैल्यू के अराउंड हमें चूज करना. Just give me 1 second. So now that you have actually also gone through the engine feed, I will now show it you how does the engine feed architecture actually work. So in the FCOM, if you actually go through the engine feed or the engine feed, it talks about the general aspects, it talks about the main components, it talks about engine feed, and then it talks about the fuel feed sequence. The most important, so main components and engine feed में वो एक philosophy देगा और components को बताएगा. Now here how it actually operates the fuel system so as to keep the maximum amount of fuel in the outer tanks for as long as possible is going to be our decision. Is what we will be actually learning in the fuel feed sequence chapter. It has some automatic functions of center tank inhibition. That becomes the really really most important parts of this chapter, and वहाँ से ही questions पूछे जाते हैं. That is something that we have to study. Let's have a look how. Have two architectures in front of us. One is the classic architecture, which is on the left hand side of the screen, right now, and this is the other one, the with the transfer system. With the transfer system, okay. There are also other systems where you have a transfer system. There are also other configurations in which So this has a center tank, inner tank, and an outer tank, right? There are also configurations in which you have center tank and an entire wing tank. They will follow the same. The only difference will be between the capacities. As you have seen in your FCOMs, you have a number of different capacities out there. Okay. However, if we were to philosophically talk about the difference in architecture or the fuel feed sequence, there are primarily two types. One with the transfer system, which is this one, and one without, which is the number one. Now let's study this. This is important for our exam. We have two engines. We have a center tank. We have an outer tank and an inner tank. We have an outer tank and an inner tank. यहाँ से फ्यूल की लाइन इनर टैंक से इंजन तक, क्योंकि यहाँ पे मेरे पास दो पंप्स हैं, ये दोनों पंप्स ऐसे जाए ना। ये जो तुम्हारा सेंटर टैंक है, यहाँ पे तुम्हारे पास दो पंप्स हैं, ये वाला लेफ्ट वाले को सप्लाई करता है। द लेफ्ट पंप ऑन द सेंटर टैंक सप्लाइज इट टू द लेफ्ट हैंड साइड ऑफ द लेफ्ट इंजन. The right side pump of the center tank supplies it to the right engine. Any doubts? Any doubts? No? Okay. This configuration has a total of 6 pumps. 1, 2, 3, 4, 5, 6. All the 6 pumps run continuously, but the center tank pumps run at a higher pressure. Okay. So essentially we have 3 pumps which are supplying the each engine. So you have one, two, three. Okay, 2 here, 1 here, which are supplying each engine. 2 on the on side, उसके side के inner tank और एक center tank. Okay. The center tank fuel is delivered preferentially. Means the fuel pressure that is obtained from the center tank is a little bit higher than what you get from the inner tank. That means if all the 3 pumps are working, only the fuel from the center tank will get depleted and will supply the engines. However, if the center tank is empty, the inner tank pumps will work. Any doubts? How much fuel do you need to have on board in order for you to have fuel inside the center tanks? For this, you need to understand fuel is mostly kept in the outer tanks first. You will use this particular fuel last. उसके बाद आप ये वाला फ्यूल यूज करेंगे, the inner tank fuel. उसके बाद जाके आप सेंटर टैंक का फ्यूल यूज करेंगे. ठीक है. My apologies. This fuel, as I told you, is used last. उससे पहले ये वाला फ्यूल यूज होगा और सबसे पहले सेंटर टैंक वाला फ्यूल यूज होगा. Why so? We want the center tank to be consumed as soon as we can. We do not want to consume fuel from the wing tanks. Why is this so? This is due to the wing bending moment. The wings produce lift, and the maximum weight of the aircraft is coming from the fuselage. Because of this, at the roots of the wings, you have a lot of bending stress. In order to prevent this bending stress from developing over and over and over and over time over a number of cycles, you tend to keep more fuel on the wing tanks than on the center tanks. That is why the first fuel that we consume is the center tank fuel. However, however, for the purpose for takeoff, you will not be using the fuel from the center tank. Why so? Because of a safety reason. You have fuel in the wing tanks, you have fuel in the center tanks. Ideally, the center tank should be supplying the fuel because that has to be depleted first. But it does not happen in the case of a takeoff. Why is that so? Because let's say if there is a pump failure of the booster pumps during a takeoff, The fuel which was being supplied by the center tanks. Fuel essentially has to come from the bottom of the engine, go up again, and then come here. We do not want to take this risk. Instead, we inhibit the center tank pumps to be operative, and the wing tanks and the wing tanks that we have had over here, they preferentially supply fuel to the engines during takeoff, so that even if you have a pump failure inside this particular thing, ये gravity से तो suck होते रहेगा. Clear? Now, on the other MSN, where you have the transfer system. In the first MSN, you had a pressure differential. इस ये वाला pump ज़्यादा pressure पे supply करता था. Here, the architecture is a little bit different. Here we have four pumps, one, two, three, four. That means no matter whatever happens, fuel is only and only supplied by the inner tanks. So, sir, center tank fuel कहाँ जाएगा? As the inner tank is depleted, the center tank pours its fuel into the inner tanks. So there are four pumps which run continuously, and then there are with two pumps on each wing tank. Okay, all of these pumps run on alternating current. Why do you need these pumps if you have pumps inside the engine? You need these pumps when you have pumps inside the engine so as to prevent cavitation in the fuel lines. So as to prevent cavitation in the fuel lines. Any doubts? What is cavitation? Cavitation is the inclusion of air molecules और एयर बबल्स इनसाइड द फ्यूल लाइन्स. वेपर लॉक इसी की वजह से होता है. You must have heard about it, especially the Technam flies. Apart from these, this is the architecture or the layout. Apart from this, we have a few mechanical components, which firstly is a transfer valve over here. Okay, this is an inter-tank transfer valve. This is an inter-tank transfer valve. Fuel can transfer from the outer tank to the inner tank when the inner tank is depleted. Okay, so it's a separate reserved compartment that we have. It is a separate reserved compartment that we have, which basically gives us 45 minutes of fuel. The outer tanks give me 45 minutes of fuel. Okay, so the inter tank transfer valves, what are they? They are electrical transfer valve. They are an electrical transfer valve. What does it mean? फ्यूल क्वांटिटी इंडिकेटर जो कंप्यूटर है, वो जब सेंस करेगा कि यार मेरा जो आउटर से जो इनर टैंक का जो फ्यूल है, मेरे इनर टैंक में देयर इज अ लो लेवल ऑफ द फ्यूल, देयर इज अ लो लेवल ऑफ द फ्यूल, ये वाल्व्स खुल जाएंगे. आइडियाज हो. लुक एट, मेरे को जब फ्यूल कंज्यूम करना है तो मैं कैसे कंज्यूम करूँगा? ऐसे, सेंटर, इनर, आउटर. मुझे जब रिफ्यूल करना है तो मैं कैसे रिफ्यूल करूँगा? आउटर, इनर, सेंटर. ओके, कंज्यूम, रिफ्यूल, consume, refuel. Clear? So when I'm consuming fuel, my center tank is depleted. Then my inner tank is depleted. Once my inner tanks reach a lower level, which is about 750 kgs, that is when the low level sensor actually gets triggered, then the fuel quantity indicator wants to consume the outer tank fuel, but you don't have pumps in the outer tank. So what do? You transfer that fuel using these inter-tank transfer valves कि भाई outer tank का जो fuel है वो अंदर आ जाए inner tank. So it transfers the fuel outer to inner. हर विंग में दो ऐसे valves होते हैं. हर विंग में दो ऐसे valves होते हैं. अब now let's say लेफ्ट विंग पे एक लो लेवल सेंसर, सो यहाँ का वाल्व नंबर 1 और यहाँ का वाल्व नंबर 1 दोनों खुल जाए. अच्छा, व्हाट इफ राइट वाला विंग में एक लो लेवल सेंसर, तो देन दोनों विंग्स का नंबर 2 वाला वाल्व खुलेगा. So the left wing low level sensor is connected to number 1 valves in both wings. Left side का जो wing है, wing number 1, wing number 2, this particular wing, if it has a low level sensation, he will send a signal to number 1 valve and the number 1 valve in this case. So this is connected to this and this. Okay, यहाँ पर अगर low level sense हुआ, it is connected to this and this. Any doubts? Any doubts? No? पक्का? What does this mean? This means if any one of the wing tanks or the inner tanks senses a low level in the fuel, fuel नीचे आता है, outer से inner में आ जाएगा. Any doubts? No doubts? पक्का? Once open, when do these valves close? These valves close automatically during the next refueling. There's a question for this as well. So when the fuel refueling is happening, refueling हमेशा outer tank से होती है. जब outer tanks पे fuel बढ़ेगा, वो फट करके valve को भी बंद कर देगा. Okay? Now, talking about the cross feed valve. Look at the architecture. This is your entire wing. This is the center tank. In the center tank, you have pump number 1, you have pump number 2. Okay, they are supplying the fuel. The fuel can go over here to the engines as well. However, the fuel can also go down to the APU's line. Again, the APU's pneumatic was covered from the left hand side. Here, the APU's fuel is also from the left hand side. Okay, let's talk about the wing tanks. Here you have two pumps. Look at this particular thing. These are sequence valves. These are sequence valves. One second. So these sequence valves, or better known as suction valves, what do? If these pumps fail, if these pumps fail, वो यहाँ से suck in हो जाएगा fuel. Okay. So the suction valves, if the tank pumps fail, the low pressure pump, which is inside the engine, sucks the fuel from the tanks. But the only thing is, wing tanks only. It can only suck in fuel from the wing tanks because the suction valves are in the wing tanks. You will not have suction valves in the center tanks because it is at a elevation which is lower than the engine. Okay, which is lower than the shaft of the engine. Okay, so the gravity fuel feeding is not possible from the center tank. Wait out. This suction valves opens when the tank pump fails. When the tank pumps are operative, when the tank pumps are operative, they're zooming in fuel here and it shuts this particular valve. So basically, अगर यहाँ पे suction है, यहाँ पे तुमको fuel का pressure मिल रहा है, तो ये valve बंद हो जाएगा. जैसे ही यहाँ पे pressure drop हुआ, जैसे ही यहाँ पे pressure drop हुआ, fuel can gush in from here due to suction effect. Have I made my point clear? कोई doubt? ये तुम्हारा हो गया पूरा fuel का redistribution
भाई एक
system.
बार वापस बताना एक बार वापस बताना ये वाला.
So can you see these two valves?
Yes.
These are suction valves, better known as sequence valves.
Okay.
As long as the pumps are working, एकदम तब प्रेशर दे रहा है ना, एकदम वो सब टाइट करके एकदम बंद कर देगा इस ये पर्टिकुलर वाल्व्स को. क्यों? क्योंकि यहाँ पे तेरे पास बहुत अच्छा खासा पॉजिटिव प्रेशर है जो पंप तुझे दे रहे हैं. मान ले पंप नहीं काम कर रहा, तो ये पर्टिकुलर पूरी डक्ट प्रेशराइज रहेगी नहीं रहेगी फ्यूल से. सो इन दिस केस दिस वाल्व विल ओपन अप एंड फ्यूल अंदर गशड हो जाएगा इसके. अगर ये पंप्स फेल कर गए, अंदर प्रेशर ड्रॉप करेगा, fuel will get sucked in through these valves. These valves are earlier closed due to the positive pressure of the pump. Now the pumps are no longer working, they can get open and the fuel can get sucked in. Understood? We also have transfer valves. I have discussed these transfer valves with you. Okay. We also have the LP valve. This is the final valve of the fuel system. इसके बाद engine आता है. So the LP valve or the low pressure valve के just downstream is the low pressure fuel pump of the engine. That is why this valve is known as the LP valve, and it is controlling the fuel to the engine. When you press the engine fire push button, this is the valve which closes. It shuts off complete fuel supply to the complete of the engine. There is one more HP fuel pump. There is one more HP fuel pump, but again, fire push button controls the LP valve. Am I clear? So the LP valve is controlled by the engine master switch and the engine fire push button. Any doubts? What does it do? Controls the flow of the fuel to the engine. Quite out. When you turn the engine master lever to on, the LP fuel valve will open and the HP fuel valve will open. When the engine master is off, both these will close. However, when the engine master is on and you press the engine fire push button, the LP valve will close. I hope I've made myself clear. Okay? Talking about the APU. Talking about the APU. The APU feed line लेफ्ट साइड से है, कोई डाउट है इसमें? कोई डाउट नहीं. यहाँ पे हमारे पास एक एपीयू का पंप भी. क्या ये पंप नेसेसरी है? हाँ. बट क्या ये हमेशा चलता है? नहीं. As long as you have pressure from the main engine fuel pumps, this APU pump will not work. It only supplies the fuel in case of there is the tank pump failure or the tank pumps are off, or there is a complete AC power supply failure. Tell me something. If there is a complete AC power supply failure, how is this particular pump working? If there's an AC power supply failure, this is working because it is powered by the AC essentials shed bus and by the static inverter bus. So no matter whatever you do, the static inverter bus तो है ना हमारे पास, बैटरी से तो चल ही जाएगा. That is why we say that the APU can start on batteries also. But yes, if the batteries are off, then the APU cannot start. Okay? But this is only for the purpose of fuel. Will the APU start if you have AC power but the batteries are off? Yes. Any doubts? Now let's study the fuel feed sequence, which is primarily the most important portion of this chapter. The fuel feed sequence is CIO. Ciao. Bella ciao. We first want the ACTs to get consumed. So you have ACT 3, 2, 1. We want them to consume first. Then we consume the center tank. Then we have the inner tank and then the outer tank. Okay? But we have a problem here. Now what we are going to do is we are going to assume that we have a completely full engine tank. Full पूरा मेरा सारा A320 के जितने भी सारे fuel tanks हैं वो full. Tell me something. Is it advisable to take fuel from the center tank right now? No. Why? See, you need to understand that there's something more to the engine. There is a fuel recirculation system in place as well. Can you see this? This is the fuel recirculation system. Look at this. The fuel recirculation system is taking it to which tank? The outer tanks. And the outer tank, if it is full, it will spill it onto the inner tank or the wing tanks basically. Right? So if the fuel is being recirculated, where is it being pushed? It is being pushed to the inner tanks. So can I have The center tanks supply the fuel. Is my inner tanks are completely full? Okay. So मान लो कि तुम्हारा ये भरा हुआ है, ये भरा हुआ है। अब यहाँ से फ्यूल तुम्हारा जाएगा इंजन के अंदर, है ना? फिर वो रिसर्कुलेट होकर कहाँ, यहाँ पे आएगा। भाई यहाँ ओवर प्रेशर नहीं हो जाएगा? ऑफ कोर्स यहाँ पे ओवर प्रेशर हो जाएगा। So I know we want the center tank fuel to be consumed first, but not at the cost of the wing tank being overpressured or the inner tanks being overpressured. So इसीलिए अगर तुम्हारे सारे टंकियां भरी हुई हैं, सेंटर टैंक भी भरा हुआ है, your entire thing is completely full, at engine start the center tank pumps run for 2 minutes regardless of slat track position. You always basically want 500 kgs of fuel to be consumed from the inner tank first. आपको एक बेसिक तुक बता देता हूँ। मेरे इनर टैंक से जब जब तक 500 केजी कम नहीं होगा ना फ्यूल, तब तक वो इनर टैंक से ही सप्लाई लेगा। क्यों? क्योंकि फ्यूल रिसर्कुलेट होकर यहाँ पे आएगा, फ्यूल की क्वांटिटी बढ़ेगी, तो मेरे को उसके लिए स्पेस चाहिए। सो यू विल फर्स्ट मेक श्योर दैट यहाँ पे the wing tanks have reached the under full sensors. They have reached the, मतलब it is not full, it is under the full. So there are three sensors. It has a full sensor, it has an under full sensor, and it has a low level sensor. How many sensors we have? Full, under full, low level. Clear? Once this is done, then you will consume the center tank fuel. सेंटर टैंक फ्यूल भी आप तब तक ही कंज्यूम करोगे, सेंटर टैंक फ्यूल भी आप तब तक ही कंज्यूम करोगे जब तक आप टेक ऑफ नहीं करोगे। टेक ऑफ के टाइम पे वापस इनर टैंक पे आ जाओगे। ठीक है? ठीक है, अब अगर तुमने टेक ऑफ खत्म कर दिया, मतलब तुम्हारे स्लैट्स रिट्रैक्टेड हैं, तुम एक्सेलरेट कर चुके हो, then the center tank fuel will be consumed, all the 6500 kgs will be consumed, then the inner tanks will be consumed. इनर टैंक्स जब तक तुम्हारा लो लेवल पहुंच जाएंगे ना, फिर क्या होगा, ये ट्रांसफर वाल्व्स खुल जाएंगे और दे विल पोर इन मोर 750 kgs. सो इनर टैंक में जब 750 kgs है, तभी ये वाल्व्स खुल जाएंगे एंड दे विल पोर इन मोर 750 kgs. Clear? Now let us understand the fuel feed sequence. The fuel feed sequence, see, fuel feeding sequence starts from where? When? Since the time you start feeding the fuel. When do you start feeding the fuel? At engine start. So it only becomes relevant, it does not become relevant from the parking bay, it only becomes relevant from engine start. So let's say you're starting the engine. The center tanks will run for 2 minutes regardless of the slat position. So during engine start, what pumps are running? Center tank pumps are running. Okay. So center tank for how many minutes? 2 minutes. The center tank is inhibited. The pumps are inhibited. For 2 minutes. जब जैसे ही वो 2 मिनट बंद हो जाएंगे, 2 मिनट खत्म हो गए, इंजन स्टार्ट कर दिया, 1 second. Yes. Can you hear me? Yeah. So at engine start, the center tank pumps will run for 2 minutes regardless of the slat position. Now this becomes irrelevant because flaps will not be at config full. Flaps will either be at config 1 or they will be at config 0. पार्किंग के टाइम पे आप यही दो कॉन्फ़िग रखते हो और कोई दो कॉन्फ़िग रखते ही नहीं हो. करेक्ट? हैव आई मेड माय पॉइंट क्लियर? नाउ लेट्स टॉक अबाउट द सेंटर टैंक inhibition logic. The center tanks will be inhibited when the 2 minutes are up, okay, and the slats are extended. मतलब इंजन स्टार्ट हो गया, इंजन स्टार्ट हो गया, 2 मिनट तक सेंटर टैंक चल रहा है, गुड, द सेंटर टैंक्स आर रनिंग फॉर 2 minutes. Now this entire computer, the fuel feeding sequence computer, you know what will it do? You know what will it do? वो सेंटर टैंक्स को बंद कर देगा. किसके बाद बंद कर देगा? इंजन स्टार्ट होने के बाद एंड स्लैट्स एक्सटेंड होने के बाद. अब सी, it becomes obvious for us. They have made these two cases, but you need to understand. जैसे ही तुम engine start करते हो, what is the first thing that you do? Ground spoilers on, mode select to normal, flaps to take off configuration. तो कोई भी तुम फ्लैप एक्सटेंड करोगे तो तुम्हारे स्लैट्स तो आ ही जाएंगे ना, क्योंकि स्लैट्स पहले आते हैं. सो दिस इज ऑब्वियस बिकॉज ऑफ द आफ्टर स्टार्ट. कोई डाउट? On ground, how much is the fuel consumption? It's about 300 kgs an hour for both engines. For one engine, it would be 150 kgs an hour. So, how much fuel are you consuming per hour? 150 per engine. Why are we doing this inhibition? We are doing this inhibition because we want the inner tanks to supply till that point of takeoff. तो जैसे ही तुमने इंजन स्टार्ट खत्म कर दिया एंड तुमने स्लैट्स एक्सटेंड की, कंप्यूटर बोलेगा कि यार इस बंदे ने इंजन स्टार्ट कर दिया, इस बंदे ने स्लैट्स एक्सटेंड कर दिया, पक्का टेक ऑफ करने जा रहा है. गॉट इट? सेंटर टैंक बंद कर दो, सेंटर टैंक इनहिबिट कर दो. इनर टैंक्स कब तक सप्लाई करते हैं? इनर टैंक सप्लाई द फ्यूल फॉर डिपार्चर टिल द टाइम यू रीच स्लैट रिट्रैक्शन. मतलब तुमने कन्फिग 1 से कन्फिग 0 कर दिया है. कन्फिग 1 का सबसे तुमने कन्फिग 0 कर दिया. दैट मींस कन्फिग 0 कर दिया तो ऑफ कोर्स मतलब बात क्या होगी? टेक ऑफ सेगमेंट खत्म है ना, मतलब तुम्हारा एक्सेलरेशन हो गया. अंडरस्टूड? सो व्हेन इज द सेंटर टैंक पंप इनहिबिटेड? The center tank pump is inhibited when till the time point you have consumed 500 kgs of fuel, and the center tank pump is inhibited for the purpose of takeoff. Okay, takeoff on center tank feeding is prohibited. This is under the limitations which is only found in the AF. Reason क्या है? If the booster pump fails, the engine can be continue to be supplied by the gravity field. Now then there is another reason for the, or another situation in which the center tank is inhibited. If the 500 kgs of fuel जब तक कंज्यूम नहीं हो जाता इनर टैंक से, जो मैं आपको सिखा चुका हूँ. वाई? फॉर द पर्पज ऑफ फ्यूल सर्ज ड्यू टू रीसर्कुलेशन. सो नाउ लेट्स से तुमने अगर स्लैट रिट्रैक्ट कर दिया, लेकिन वो ये देखता है कि यहाँ से 500 kgs फ्यूल कंज्यूम नहीं हुआ, यहाँ से 500 कंज्यूम हुआ, will it run the center tank? No. Let's say you started your engines, both the engines, you were on ground for 1 hour. That means how much fuel did you consume? 300 kgs. मतलब 150 from the left, 150 from the right. You're taking off at full fuel. तुमने स्लैट रिटेक्ट कर दी, तो यहाँ से 150 गया, यहाँ से 150 गया, क्या तुम्हारा सेंटर टैंक चलेगा? सो द सेंटर टैंक विल ओनली रन इफ यू आर नॉट इन द टेक ऑफ सेगमेंट, एंड यहाँ से 500 500 गायब होना चाहिए. ओके, एक बार वो हो गया, देन इट्स इन सेंटर टैंक, इन टैंक, आउट टैंक. एक बार वो 500 500 हो गया, फिर सेंटर टैंक ऑपरेट कब तक करते हैं? जब तक सेंटर टैंक लो लेवल नहीं पहुंचा. एक बार लो लेवल पे पहुंच गया ना, उसके बाद भी 5 मिनट और ऑपरेट करेगा, सूंघ लेगा भाई वो पूरा वहाँ से फ्यूल. एक बार सेंटर टैंक खाली हो गया, फिर इनर टैंक सप्लाई करेगा. कब तक? जब तक वो खाली ना हो जाए 750. एक बार वो खाली हो गया, देन अ सिग्नल इज सेंट for the inter-tank transfer valves to open and pour fuel into the inner tanks. FCOM limitations, what is the minimum fuel for takeoff? 1500 kgs. Any doubts in today's class as of now? No? Pakka? Now you guys tell me, do you have any doubts in this entire center tank inhibition logic? No? So, what you do is, fuel feed sequence जो लिखा हुआ FCOM, go through that, उसको पढ़ो, और जो मेरे नोट्स में यहाँ पे लिखा है उसको पढ़ो, कंपेयर इट and make your own understanding of it. हो सकता है आपको FCOM better लगे. Some people find the FCOM better. I find this particular system a little bit more simpler. Okay, this is a, I would say it's a little complicated portion of the syllabus. So I want you guys to take 2 minutes and give it 2 minutes of your own. Okay, please have a look. Okay, Smith, you can ask your doubt now.
एफकॉम में जो इफ द एयरक्राफ्ट हैज वन एसीटी, वो वाला जो ट्रांसफर वाला पार्ट है उसमें थोड़ा समझ नहीं
Open the
आया।
FCOM. I'll explain you the ACT transfer as well. See, ACTs are considered as center tanks, right? So they will follow the center tank inhibition logic as well. Okay. So open the FCOM. What emissions are you referring to? The emission in which the last two sections, if the aircraft has one ACT, ACT to center tank transfer. If the aircraft has two ACTs, ACT 1 plus 2 to center tank transfer. Those sections? Is that where you have a doubt? Okay. Let's have a go through this. The additional center tank is the center tank itself, right? Tell me something. You take off. Where, after what time do the center tanks start to work?
एक्सेलरेशन फ्लो के बाद.
Acceleration flow, slat retraction. अभी तो पढ़ा था. When your slats are retracted, right? So as soon as your slats are retracted, fuel will start getting consumed from the center tank. Now tell me something. If you have some fuel in your additional center tank and you have fuel in your center tank, which fuel should be consumed first? Center tank out, additional center tank fuel.
Is which supersedes this acceleration or 500 kgs?
Depends situation to situation. For example, okay. So I'll solve Krish's question first because it's a more relatable question. Krish, let's say you're taking off with full fuel, that is 19 tons. Okay, you do your taxi on the ground, you consume about 100 kgs. So is your center tanks, so आपने engine start कर लिया और आपने slats extend कर दी, configurations दे दी, आपने engine start. Will the center tanks run? The center tanks will not run. The inner tanks will run. Cool. After you take off and you retract the slats, do you think you will have consumed 500, 500 each from the inner tank? You wouldn't have consumed. In that case, the inner tanks will continue to run because you need to have minimum 500 consumed. Now let's say you have some amount of fuel from your, let's say you're taking off with 7 tons of fuel. If you have 7 tons of fuel, that means there is zero fuel in the center tanks. That means there is zero fuel in the center tanks. Do you agree? So center tank pump तो already inhibited है. So इसमें तो वो logic काम ही नहीं करेगा. Now, however, listen to this particular logic. Let's say you have about 300, 400 kgs in your center tank, and your inner tanks you have 3 tons each in your inner tanks. I know. Usually center tank में से fuel हम लोग रखते नहीं, but manual refueling was done, and you have some fuel in your center tanks. You have 3 tons of fuel in your wing tanks, or which are your inner tanks, and your outer tanks are full. Now you start your engines and you take your slats and flaps. What will run? The inner tanks will run. The inner tanks will run. The center tanks will not run. The center tanks has some fuel. It has 500,000 kgs of fuel. Okay, let's say you take off, you retract your slats. Now the control logic will sense, has my takeoff segment completed? Yes. Does the center tank have more fuel? Yes, it has. So the center tanks will run. Now the center tanks are running. कोई problem है with the center tanks running? Is there a problem with the fuel recirculation? No. Is there enough space in the inner tanks? Yes. So the center tanks will run. So Krish, we are going to take the first example, which is where we had full tanks. Then we are taking the second example, where the inner tanks were not full. So you have taken off, you have retracted your slats. There are two checks. First check is slat retracted. Second check is inner tank below 500, below 5500. If both of these meet, then only center tanks run. If either of this is not meeting, that means if your slats are retracted but your 500 has not been consumed, inner tanks will keep on.
So इसका मतलब it has to be 500 less than the full.
full.
It's
It
5,500.
is 5,500, but I'll tell you the FCOM really does not tell you 5,500 somewhere. Basically, it tells you under full sensors because जब aircraft जब जाता है, aircraft is a dynamic thing. It can move it. So similarly, the fuel inside the tanks can also move. When the fuel reaches the under full sensor, no, then it activates. Now, on a given day, the under full sensor can get activated in a maneuver beforehand also. And maybe there is turbulent. The fuel has actually, you have consumed 500 kgs of fuel, but the under full sensor is still wet due to turbulence and the fuel moving around. So the correct lingo would be the fuel reaches the under full sensors. Am I clear? Now, Subal, for you, तुम्हारे slats retract हो गए. Have you got the answer, Krish? Subal, for you, you retract your slats. You have an additional center tank. You have a center tank. Which fuel should be consumed first? Additional center tank fuel should be consumed first. So when does the additional center tank transfer starts? After slat retraction, right? If the center tank high level sensor has been dry for 10 minutes and the ACT is not empty, so मतलब वो देखेगा कि तुम्हारा सेंटर टैंक में खाली जगह है. सेंटर टैंक का जो हाई लेवल सेंसर है वो 10 मिनट से ज़्यादा सूखा पड़ा है, मतलब अंडर फुल हो चुका है. That means there is some space in the center tank. It means there is some space in the center tank. And there is fuel in the additional center tank. Then the transfer will start. Now, let's say तुमने स्लैट अटैक कर दिया, सेंटर टैंक फुल भरा पड़ा, क्या एडिशनल सेंटर टैंक ट्रांसफर करेगा उसमें फ्यूल? नहीं, जगह नहीं है, कैसे करेगा? सो सेंटर टैंक से फ्यूल कंज्यूम होगा तो हाई लेवल सेंसर ड्राई हो जाएगा. वो ड्राई होने का 10 मिनट बाद ट्रांसफर शुरू होगा. गॉट इट? कोई डाउट? कोई डाउट? नो डाउट. ओके. हाउ डज दैट center tank additional center tank to center tank transfer system work? ये भी मैं आपको सिखाने वाला हूँ. ओके. Go to the next paragraph. If the aircraft has two ACTs, if the aircraft has two ACTs, which ACT transfers first? ACT2 transfers first, then the ACT1 transfers. Clear? इधर से आपको यही अभी तक पढ़ने की जरूरत, और कुछ पढ़ने की जरूरत नहीं. Shall we go to refueling? Shall we go to refueling? Or do you want to study the
Sorry, I
ACT?
have
I can teach you
a
ACT
question.
transfer, but it won't come as a part of our exam. Yes, Krish, you were saying something?
I was saying, what is the logic? Is it the logic is, for example, let's say मैं 4,500 inner पे take off कर रहा हूँ, so उसका logic associated 5,500 से है या फिर 500 burn से है from what you took off at?
Come again.
Does that make sense? So if I'm taking off at 4,500 in inner tanks, and now I've retracted, say, the flaps or slats, uh, now will is the logic that I have to burn 500 from 4,500, or
No,
is it
no.
associated with
It is
5,000?
associated with the full capacity of the inner tank.
Okay,
So,
got it.
if the full capacity of the inner tank is 5,500, you have to have less than 5 tons of fuel. If you're taking off with 4,500, the system after slat retraction will check, is this fuel
भैया
500
आपका
tons?
स्क्रीन शेयर नहीं हो रहा.
Is it? Okay. Okay. So जो आपका additional center tank है, I can teach you that additional center tank also, but exam में आता नहीं. You want me to quickly go through it? ऊपर ऊपर से. Open your FCOM. I will teach you this from the FCOM. Please go to the additional center tank system, which is 281040. Go to 281040. Okay, are we all at the additional center tank system? Please have a look. Go to the diagram. ACT system architecture. Can you please go to the system architecture diagram? हाँ जी, सब लोग चले गए? Please give me a thumbs up if you have gone there. Now, look at the ACT transfer valve. Can you see that it is ACT transfer valve? Can you see the center tank in the middle? Can you see the center tank in the middle, guys? दिख रहा है ना? अब ये सेंटर टैंक के ऊपर एक एडिशनल सेंटर टैंक है, नीचे दो एडिशनल सेंटर टैंक्स हैं. ओके, कोई डाउट? Now, let us look at the pipelines on the right hand side of the screen. There are pipelines on the right hand side of the screen. From these pipelines are responsible for taking the fuel from the center tank and delivering it to the center tank. ये additional center tank से fuel लेती हैं pipelines and ये center tank में डालती हैं. So let us have a look at the upper forward additional center tank. Can you see that inlet valve? Can you see that inlet valve? Your FCOMs do not have the additional center tanks. So what we are going to do is, in that case, I'm going to teach you additional center tanks sometime later. Okay? Let's straight away then go to refueling and defueling. Let's go to APU feed first. We have studied APU feed. You can go to APU feed. A special fuel pump supplies fuel for the APU startup when the fuel pressure is low. We have studied this over here. Okay, that is covered. Then we have the fuel recirculation system. The fuel recirculation system, as I have showed you earlier in the class, it will be covered under the engines chapter. The fuel recirculation system. Okay, this fuel recirculation is for information only. Quite out. Now we will straight away go to 281070. That is refueling. Okay, open it in the FCOM. In the FCOM, you will, in the very first DU, you will be shown the diagram of an A320 with all the different panels marked. With all the different panels marked. Are we all there? Are we all at the same page? Great. Have a look at the external refuel panel. So this external refuel panel is basically a panel which the ground personnel, the refueling personnel opens. He sets in a fuel figure and then he starts the refueling. Where is the refueling pipe connected to? Look at the wing on the left hand side of the display, which is basically the right wing of the aircraft. Can you see a refuel couple? That is where the refueling hose goes in. All other panels are optional. You can also have a refuel coupling on the left hand side of the wing, but that is an optional equipment. That is an optional equipment. I hope I've made myself clear. What is primarily important in the refueling section is that you have one external refuel panel and you have one refuel coupling. Where is it? On the fuselage below the leading edge of the right wing, and refueling coupling is below the right wing. There are also other refueling points on the top of the wing where you can refuel by the gravity. The entire refueling system is automatic in nature. The entire refueling system is automatic in nature. Okay. However, manual control is also available. आप क्या करते हो? वो पैनल खोलते हो, फ्यूल की वैल्यू डालते हो. कहाँ डालते हो? जहाज में डालते हो. And what you do is you take the fuel truck, you connect the hose to it, and you let it happen. So basically जो fuel truck है वो fuel continuously डालते जाएगा. What does the fuel quantity indication do in the aircraft? वो refueling control करते हैं. The FQI and the FLSCU systems, they control the refueling. They control the refueling. आपने जब उसमें वैल्यू सेट कर दी, अब वो क्या करेगा? This computer, he will take the fuel and he will distribute the fuel in the outer tanks, inner tank, and the center tank via its own control logic. via its own control logic. Any doubts so far? When the fuel on board reaches the pre-selected figure on the panel, वो refueling के valves को बंद कर देगा. As soon as the fuel quantity is reached, the refuel valves gets closed. For refueling to happen, you need battery power. It is a mandatory thing. कोई doubt? As I told you, CIO इसका उल्टा है OIC. But there is a slight catch here. The sequence for the refueling is OIC, which is the opposite of CIO. Auto refueling में क्या होता है? Auto refueling में outer tanks. Let's say you have pre-selected a quantity of 9 tons. So I know 750 kgs, 750 kgs, both of them will go in the outer tanks. 750 kgs, both of them will go in the outer tanks. बाकी बचा कितना? 7 tons था, तो 1500 चला गया, 5500 बचा, divided it into 2, 2750 here, 2750 here. That is the amount of fuel that you will have. कोई doubt? पक्का? Great. Now tell me something. सेंटर टैंक इसमें जरूरी है भरना? नहीं है, खाली रहेगा. सेंटर टैंक कब भरेगा? सेंटर टैंक तब भरेगा जब करीबन आपका जो फ्यूल है वो 12 टन से ज्यादा होगा, उसके बाद ही भरेगा. समवेयर अप्रोक्सीमेटली 12.5 टन से जब ज्यादा होगा तभी भरेगा. So in auto refueling, what happens is first the outer tank gets supplied with fuel, and only the outer tank gets supplied with fuel. Fuel then spills onto the inner tank with the help of a spill pipe. This will ensure that there is always the outer tank is full and the inner tank is supplied with the remaining amount of fuel. If the fuel on board is supposed to be more than 12 tons, then the center tank is filled simultaneously. If the refueling is manual in nature, then it outer tank से inner tank जब एक अप्रोक्सीमेट फुल लेवल पे भर जाएगा ना, उसके बाद ही सेंटर टैंक भरेगा अंडर द मैनुअल रिफ्यूल. So the fuel is fed into the outer tanks. I want you guys to go to the refueling wala section, refueling and defueling. Scroll down, scroll down to find the second diagram in that DU. So when the fuel is fed into the outer tank, have you opened the image from the FCOM? Good. Can you see the refueling couple there? The refuel coupling there. दिख रहा है ना refuel coupling? That refuel coupling देखिए वो कहाँ पे जा रहा है? तो पूरा एक central rail में जा रहा है. Refueling gallery में जा रहा है, right? Can you see it? Can you see it? That refuel coupling is going all the way to the refueling gallery. Before it actually goes to the refueling gallery, it goes a little to the left to the refuel valve. You can zoom into the diagram to view it. Refuel coupling, and it moves slightly to the left as soon as it enters the refueling coupling through the refuel valve. Have you seen it? The fuel is, see, it is going to the outer tank. When the outer tank is full, can you see close to the surge tank there's a pipe coming out? That pipe is marked as the spill pipe, which then spills the fuel onto the inner tank. Clear? And then the refueling gallery के मदद से you can actually put fuel into the center tank as well as onto the additional center tanks. Cool. So the fuel is fed into the outer tanks. If the outer tanks are full, it spills into the inner tanks via the spill pipe. In the process of doing so, in the process of refueling, if the outer tank transfer valves have been opened, they will get closed automatically. As I told you, they will be closed during the next refuel. If the pre-selected fuel quantity exceeds the wing capacity, or the capacity of the fuel in the wings, which is basically close to 12 tons, that means the center tank needs to have fuel. If it is automatic refueling, the center tank will be filled simultaneously. However, if it is manual refueling, center tank refueling will take place after the inner tank. Clear? How much time does it take for refueling? If you have to only fill in the outer and the inner tanks, 17 minutes. If you have to fill in the center tank, 20 minutes. Plus one more ACT, 25 minutes. Plus second ACT, 27 minutes. Have I made myself clear? These are the timelines which are required. Any doubts that you have from the refueling section? No? Shall we proceed with the FTIS, fuel tank inerting system? Let's now talk about the fuel tank inerting system. FTIS, or the fuel tank inerting system, can you all go to 28, 10, and 90? 28, 10, 90. It's a very small section. This is a separate section with separate function which has been created because of the, see, what was the basically the problem is that the center tank has a high flammability exposure owing to the brakes in the vicinity, the air conditioning packs in the vicinity, and the bleed air sources in the vicinity. So what you usually do is, because you have kept keeping fuel and high temperature together, you are sending oxygen depleted air into the center tanks instead of normal air. This will reduce the exposure to flames, or basically it's making an inert environment for the purpose of combustion. Okay, so what is there? A nitrogen rich or a oxygen depleted air is being sent towards the center tank. Have I made myself clear? Yes. So कब से कब तक शुरू होता है? इंजन स्टार्ट से इंजन शट डाउन तक शुरू होता है. इसका कोई क्रू को इंडिकेशन है? नहीं. क्रू की कोई इनपुट चाहिए? नहीं. So you're taking air from the bleed air, which is basically hot air, 40 psi, high pressure air, 200 degrees Celsius. You're going, making it go through something known as a CSAS, conditioned service air system. What does it do? It's basically very much close like a air conditioning pack. It is very much close to an air conditioning pack. It adjusts the temperature and the pressure of the bleed air. Okay. Then it goes through the IGGS. This is the main functional component, inert gas generation system. Inert gas generation system. Basically, what it does is it taps the N2 molecules and produces the oxygen depleted air. तो वो नाइट्रोजन वाले मॉलिक्यूल्स को टैप इन कर देगा, एंड वही नाइट्रोजन वाले मॉलिक्यूल जिसको टैप इन किया फिर उसको सेंटर टैंक में भेजता है. कोई डाउट? दैट इज योर फ्यूल टैंक इनर्टिंग सिस्टम. बंद कब होगा? जब इंजन ऑफ हो जाएंगे. हैव आई मेड माई सेल्फ क्लियर? नाउ लेट्स गो टू 281080, the fuel quantity indication. We are reaching towards the end of the chapter. There are two computers. You have the fuel quantity indication system, or the FQI, fuel quantity indicator computer, and you have the FLSC, fuel level sensor control, and they both have their own different functions. एक लेवल सेंसर है, एक क्वांटिटी सेंसर. ये तुम्हारा फ्यूल है, फ्यूल का लेवल कितना है वो ये सेंस करता है. इट मेजर्स द फ्यूल लेवल एंड द टेम्परेचर ऑफ द फ्यूल. ओके, इसके फंक्शंस क्या हैं? ये छोटा, दिस इज अ स्मॉलर कंप्यूटर, दिस इज द बिगर कंप्यूटर. Okay, so this smaller computer FLSCU gives some data to them. Okay, so this FLSCU, the fuel level sensor control unit, measures the fuel level and the temperature. It controls the valves during refueling and defueling. Why? See, when you're refueling and defueling, the sequence valves, as I've told you, the outer tank से inner tank में जाएगा and center tank simultaneously fill होगा. So when the center tank is filled, maybe center tank was supposed to be filled with maybe 500 kgs. So who will turn off the five center tank refueling when it has hit 500 kgs? The FLSCU will. As soon as the FLSCU senses कि यार 500 पहुंच गया, as per its own calculation, it will turn the refueling valves off. Okay. Also, this computer is responsible for the transfer systems. That is, from the center tank to the wing tank you have transfers. Also, from the additional center tank to the main center tank you have transfers. This is basically under full sensor आया कि नहीं. अगर inner tank में 500 consume होना चाहिए ना, 500 kgs of fuel needs to be consumed from the inner tanks for the center tank pump inhibition. Wala logic, right? 500 kgs of fuel from the inner tanks have to be consumed before the center tank pumps continue to run, or the center tank transfers the fuel to the inner tanks. The center tank needs to be empty. The high level sensor needs to be dry for about 10 minutes before the additional center tank sends fuel to the center tank. Who is going to take care of that? All of these fuel level sensors and the transfer system are done with the help of FLSCU. The FLSCU has the following three sensors in each tank. It has a high level switch, low level sensor, and an overflow as well. Quite out? No doubts? Sure. Great. Let's talk about the other computer, which is fuel quantity indicator. It's a quantity indication system. So not only does it transmit the level, it basically gives you a quantity in kgs and its temperature. So it gives you fuel ka mass, parameter number one, parameter number two, temperature. These are the only two parameters that are displayed to the pilots on their ECAM as well. The fuel mass and the temperature. Quite out. This also controls the auto refueling as a whole. This controls the valves. This controls the refueling. So who controls the refueling panel also? This guy controls the refueling panel. It's only one computer, but it has two sub channels, identical. Clear? How does this send or measure the quantity of fuel as a mass to the ECAM? So earlier in Cessnas, what did you have? You had the fuel tank and you had this fuel level. यहाँ पे आपके पास एक फ्लोट टाइप का सेंसर हुआ करता था. अगर फ्यूल ज़्यादा होगा तो फ्लोट टाइप का सेंसर ऊपर जाएगा, फ्यूल कम हो तो फ्लोट टाइप का सेंसर नीचे आएगा, एंड उसके एंगल के प्रोपोर्शनल ऊपर और नीचे जितना गया उसके प्रोपोर्शनल आपको क्वांटिटी की इंडिकेशन मिलेगी. दैट इज व्हाट सपोज टू that is exactly what used to happen, but that measured the volume of the system. The that did not measure the mass of the system. To measure the mass of the system, you have to take this entire volume and you have to multiply it by density, and you have to multiply it by density. Any doubts? How do you do it? Let's see. So you need to have a capacitive probe to sense the fuel level and the temperature. एक कैपेसिटर का एक शीट है मेरे पास, यहाँ पे मेरे पास दूसरे कैपेसिटर का शीट है, यहाँ पे हमारे पास दो शीट्स हैं. Okay, now let's say this is my fuel tank. I have put in a capacitive probe, I have put another capacitive probe. Okay, and this is the fuel level. एक कैपेसिटर कैसे काम करता है? It has two plates and बीच में हम लोगों के पास एक डाइलेक्ट्रिक होनी चाहिए, right? So I have a particular plate, I have another plate. What is the dielectric between these two right now? It's air. अगर इसके बीच में फ्यूल आ गया, so what am I doing? I am giving a higher dielectric constant to this guy. बीच में मैंने एक dielectric substance डाल दिया, फ्यूल डाल दिया. Will this capacitor be able to handle more charge? Yes. If I put in more amount of fuel, will it be able to handle more charge? Yes. Because मैंने dielectric की quantity बढ़ा दी ना. The greater the dielectric quantity between the two electrodes, the greater the dielectric quantity between the two electrodes, the greater is the charge that the capacitive can carry. Acha, let's say the this is the fuel tank and you have 100 kgs of fuel like this, and ये तुम्हारे दो probes हैं कैपेसिटर की. दूसरा टंकी है, उसमें भी 100 kg फ्यूल है लेकिन उसका लेवल यहाँ तक है क्योंकि डेंसिटी है. What will happen? Will it sense the level or will it actually sense the mass? In both the cases, In both the cases, जो मैंने अभी आपको बताया, दोनों में 100 kg फ्यूल ही है, एक का वॉल्यूम ज्यादा है, एक का वॉल्यूम कम है. So it senses mass. How does it do it? Please have a look. So this capacitive probe measures the volume. This capacitive probe, as I've shown you right now, measures the volume of the fuel and the temperature of the fuel. You have another densiometer, aka cadensicon sensor. A cadensicon, cadence has to do with the light. So what it does is basically it's a light gun, sends some light, and with the help of the transparency or the gadhapan or the thickness of the fuel, it is able to estimate the density of the fuel. So a densiometer calculates the density. You take the volume and you multiply it by the measured density by the densiometer. So volume times density, I'll get mass. This mass is sent to the ECAM. In the case this densiometer does not work or is at fault, then you have a capacitive index compensator as a backup as well. Okay? Any doubt?
तो इनका इंडिकेशन आता है.
Asmit, mute your device. Mute your device. Now speak. Super.
मैं वो बोल रहा था कि ये जो डेंसियोमीटर अगर मैल फंक्शन होता है या फिर इनऑपरेटिव हो जाए तो उसका कोई इंडिकेशन आता है कैंप पे.
I'm not sure. I'm not sure. I will have to look it up. Okay?
एक और बार बताना भैया.
I said I'm not sure. I'll have to look it up. Okay? Any doubts? पक्का? Components क्या है? It has a quantity indicator which is on the external refueling panel, and it has a pre-selector which is also on the refueling panel. Any doubts? That is all about the fuel system. Now, let's go to controls and indicators. Please have a look at this. It's a fairly simple controls and indicators section. It's a fairly simple controls and indicators section. Please have a look. I have taken only the MSN which you're supposed to study for the exam into the account here. There is one more MSN which involves the transfer pumps from the center tanks to the inner tanks. I have not put that MSN controls and indicators over here. You can always refer to your FCOM, it is very much similar. Okay, we have 6 identical switches with respect to the 6 identical pumps. As we know, Subal, as we know that the center tank pumps have an automatic center tank inhibition logic which is shown by the auto function here. So you have 1, 2, 3, 5, 6, 7, and then you have the middle button over here. This middle button, if it is in the lights out position, it is in the auto and the center tank pump inhibition logic will take place. However, you can press this button to turn it into the man mode. In this particular case, the center tanks will pump run based on your command. So if you have turned this to lights out position, the center tanks will run. If you press it again, this will be in the off light and the center tanks pump will not run. It is completely under your control. It will not perform center tank pump inhibition logics. Am I clear? Let us understand when is this fault light for the pumps displayed. For any of the 6 pumps, the fault light is displayed whenever the pump pressure is low. No fancy extra, you know, no extra fancy reasons. Very simple. And off light simply means that the pump is at off. Any doubts so far? No doubts? Great. Lastly, we have the mode selector push button over here. You know what does the manual push button do? You know what does the manual push button do? The fault light comes on when the center tank has more than 250 kgs of fuel and the inner tank is less than 5000 kgs. So what this basically means, Krish, is I have consumed 500 kgs of fuel, okay? Then it's okay. If I've just consumed 500 kgs and my center tank is depleting, good. But if my inner tank is already depleted, it is less than 5000, maybe let's say it's 4500, and still my center tank has fuel, that means there's a problem. That means there is a problem. Because ideally it should not happen like this. The center tank pumps supply the fuel at a higher pressure than the inner tanks. It is preferentially suited for the center tanks. The center tanks pumps deliver fuel preferentially to the engines. Okay, but if it senses that there is more than 250 kgs, तो ये जो है ना, ये fault light on है. इसका मतलब ये कि आप पंप सही से काम नहीं कर रहे होंगे, इसीलिए इनर टैंक से फ्यूल गया, सेंटर टैंक से फ्यूल नहीं गया. Okay, as I've told you, the other MSN has this kind of a thing. The other MSN, look at this. यहाँ पे आपके पास एक ग्रीन लाइन है, ये इंजन 1 के पास जा रहा है, यहाँ पे आपके पास एक ग्रीन लाइन है, इंजन 2 के पास जा रहा है, और ये सेंटर टैंक इधर और ये इधर जा रहा है. ओके, दिस इज हियर द क्रॉस फीड वाल्व. In pneumatics, what did we study? We studied the cross bleed valve. This is the cross feed valve. This has two switches. Open will come out in green. That means the valve is open. 99% of the time, 99% of the time, this valve will be closed because you want to isolate the two systems. Any doubts? Any doubts? So ये वाला सिलेक्टेड ओपन है और ये वाल्व पोजीशन एक्चुअली ओपन है, दोनों में अंतर क्या हुआ? मान लो वो लाइट्स आउट पोजीशन पे, तुमने उसको दबाया. What does this mean? This means you have selected the valve open. So what will come out? The on light will come out in white. 10 seconds will pass. Then the valve will actually open. Then the open light will also come out. So when the open light is on, so open will come out in green and this will come out in on. कोई doubt? कोई doubt? अब यहाँ पर ये वाला जो पंप है, इसकी फॉल्ट लाइट कब आएगी? इसका तो पंप ही चेंज होगा. दिस इज अ जेट पंप. दिस इज अ जेट पंप. इसकी fault light तब आएगी when the associated wing tank overflows. So before I teach you about this particular fault light, you need to understand how does this system actually work. So this is the associated wing tank. This is the center tank. Open your RF.com, go to fuel, go to description, go to description, go to engine feed, go to engine feed. Under the engine feed, look at the ones which has the transfer pumps, जिसके ना डायग्राम में ब्लू कलर से भी फ्यूल मार्क्ड है. Are we all there? When you see that particular diagram, you will have a look. Here, these are my two pumps. Fuel is going to the engines with the help of two pumps. Now look at this. Fuel is also coming here. Fuel is also coming here, and it is going all the way to center tank. And when it goes to center tank, it comes out like this. Where does it come out? It comes out at the boundary of the center tank and the inner tank. So how does it help you? This is a boundary. It is pushing out fuel through a venturi. It is pushing out fuel through a venturi. अब देखो यहाँ पे मैंने यही फ्यूल उठा के इधर फेंका, तो एक बात बताओ, क्या इनर टैंक का फ्यूल सेंटर टैंक में गया? नहीं गया, इनर टैंक में ही रहा. बेसिकली आई एम रिसर्कुलेटिंग फ्लूइड इनसाइड इनसाइड ओनली. बट Because I'm pushing out fuel over here through a venturi, you know what will happen? Because of this thing, fuel which is over here will also get sucked here. क्योंकि भाई यहाँ से हवा पानी इधर जा रहा है, फ्यूल इधर जा रहा है, साथ साथ ये भी इधर से इधर सकिन होते रहेगा, साथ ही साथ ये भी यहाँ से यहाँ सकिन होते रहेगा. This type of a system is known as a jet pump. This type of a system is known as a jet pump. Any doubts? पक्का? क्लियर है? आसान लगा? So अब अगर ये जेट पंप कंटिन्यूसली काम कर रहा है और ये वाला फ्यूल टैंक ओवरफ्लो हो जाता है.
भैया 2 मिनट दोगे, एक पार्सल आया है, बस उसको लेके आता हूँ.
So when will this fault light come on? This fault light will come on when that associated wing tank overflows. ठीक है? Last portion that we're going to study is about the indicators. Please open your FCOM, go to that indicators and let's study it together. Go to controls and indicators. We have already done the overhead panel. We have need not do the ACT control panel as of now. The external refill panel and the refill panel are again not important for the purpose of your exam. We can go to the ecam fuel page. Okay, we can go to the ecam fuel page. Let's have a look. This entire section upar, are you following with me, guys? Are you following with me? आपको वहाँ पे 3-4 images दिख रहे होंगे 3-4 pages पे. Scroll on the images, scroll through the pages till you actually start seeing the description of each of these units. Scroll through it till you start seeing the description of each of these units. Okay, I hope you are there. We are going to start with center tank fuel quantity indication, which is this. So this is in green. All these values will always be in green. Anytime there's a degradation in accuracy, there will be two arrows like this over the last two digits. At any time the fuel is partially unusable, it will be like this. Any doubts? अगर ये पूरा का पूरा फ्यूल क्वांटिटी इंडिकेशन हट गया और यहाँ पर दो एम्बर क्रॉसेस आ गए, दैट मींस the fuel indicator unit or the indication itself is unserviceable. कोई डाउट? No doubts? Likewise, it is the same for wing tanks as well. Okay. The only difference between the wing tanks and the center tank fuel quantity indication is this wing tank can be in amber. When will it be in amber? It will be in amber when it overflows. Okay. कोई doubt? No doubts? Now let's talk about the pump indications. I'm going to talk about the wing tank indications first. आपके जो MSN है उसमें center tank pump indications आ रखा है पहले. I want you to go through the wing pump indications. The wing pump indications are only 2 or 3. ठीक है? Actually, normal जब आप use करते हो wing tank के pump को, अगर वो off है, it will be like this in amber. ठीक है? So after parking flows or engine parking flows, when you turn the fuel pumps off, ऐसा. अगर वो फेल हुआ तो भी ऐसा है, अगर आपने ऑफ किया तो भी एम्बर में ही आएगा. When you turn it on, it will come in green. So it's in line, that means it is in green. Okay. हम लोगों ने यही सेम चीज हाइड्रोलिक में भी पढ़ी थी. अगर ये नॉर्मली चल रहा है और इसमें लो प्रेशर है तो ये ऐसे लो आ जाएगा. एंड अगर पंप का स्टेटस नहीं मिल रहा है, हमेशा याद रखना, इट्स वेरी फिलोसॉफिकल. एट एनी टाइम यू सी एम्बर क्रॉसेस, the indication of that particular thing is on. Okay. Now we will go to the center tank pumps. Now we will go to the center tank pumps. यहाँ पे एक इंडिकेशन बढ़ जाती है, यहाँ पे एक इंडिकेशन बढ़ जाती है। वो इंडिकेशन है कि जब आप ये सेंटर टैंक पंप खुद का ऑटोमेटिक लॉजिक से बंद है ना, if the center tank pump is closed with its own automatic logic, then it will be closed in green. That is the only extra indication which is there. I hope I've made my thing clear. Okay, any doubts? No doubts? Great. So till now we have covered all these indications. We can scroll past and we can have a look at crossfeed indications as well. This is the crossfeed valve. Always remember the crossfeed valve will be in the closed position. If you have to open it, it will be like this. Okay, it will be like this. Now, when do you open the crossfeed valve? Whenever there is a fuel imbalance. There is a QRH procedure which talks about fuel imbalance. So what is the basically the procedure? The fuel procedure is, let's say you have more amount of fuel. Let's say this particular has 5 tons of fuel. This has 3 tons of fuel. Whenever the imbalance between these two is greater than 1500 kgs in flight, then you're supposed to do this procedure. What are you supposed to do? The first procedure is you're supposed to turn the crossfeed to open. The next procedure is you're supposed to turn this off. Basically, the fuel wing tank with the higher amount of fuel has to be consumed, has to supply to both the engines. Once you see, once you see that both these are reaching close to the same value, then you turn the pumps off first, on first, and then you shut this valve off. Do not do the sequence other way around. Do not turn it off and then open this valve. This will cause a lag in which this engine can cause have a flame out. Koi doubt? No doubts? Now let's have a look. Will this APU in white always come? Yes, this APU in white always comes. Is the fuel being supplied to the APU right now or no? Yes, the fuel is being supplied. Okay. When the fuel is not being supplied, how does it look? It looks like this. Okay. Go out. So the APU is being supplied? No. Is the APU being supplied? Yes. Go out. These are the normal indications. Now, open your FCOMs, go to the further indications. If this particular valve is also invalid, then यहाँ पे cross marks are. We are done with this. Now we are remaining with the three other indications of the APU. In the other three indications of the APU itself is an amber. ये जो APU यहाँ पे लिखा है ना, ये itself amber में लिखा है. ये itself amber में लिखा है. क्या क्या cases में amber? देखिए, APU valve is closed, APU fire push button switches out, master switch is on. So basically APU का valve बंद हो चुका है. कौन सा valve? Fuel valve. फायर पुश बटन बाहर है, मतलब तुमने फायर पुश बटन ऑन कर दिया, APU master on. APU master is on, but there was a fire which has been detected, which has caused the APU to be turned off. Okay, उसके ऊपर वाला डायग्राम क्या? So this thing can come on. देखो, option number one is this, APU in amber and like this. मतलब APU का फायर पुश बटन तुमने डाल दिया है और वाल्व बंद हो चुकी है. दूसरा ऑप्शन क्या है? दूसरा ऑप्शन ये है, APU का फायर पुश बटन प्रेस हो चुका है लेकिन वाल्व अभी तक बंद नहीं हुआ. It is failed open. Got it? मतलब अगर तुम फायर पुश बटन प्रेस करोगे, मान लो ग्राउंड पे एपीयू का फायर हुआ, फायर पुश बटन प्रेस करोगे, वो वाल्व को बंद कर देता है ना, एलपी वाल्व को, फ्यूल को. अगर वो नहीं बंद हुआ तो ग्राउंड पर्सन बोल रहा है सर आपने AQ5 परफेक्ट दबा दिया, हाँ दबा दिया सर, आग लेकिन बंद नहीं हुई है सर, आग बंद नहीं हुई है क्यों, ये कैम चेक करो ये खुला हुआ तो नहीं है। गॉट इट, गॉट द पॉइंट, एनी डाउट्स? So I hope you have basically understood this entire section over. When the fuel from the outer tank to the inner tank is transferred, you get this indication. You get this indication. Am I clear?
Yes.
One second. इसका पता नहीं दिया है नहीं दिया तुम्हारे एफकॉम में? हाँ दिया है ना। अगर तुम्हारे ये जो फ्यूल है ना ये ट्रांसफर नहीं हुआ है तो ये ऐसा दिखेगा, अगर ये फ्यूल ट्रांसफर हो गया और ये वाल्व्स खुल गए तो ऐसा दिखेगा। ठीक है, नाउ यू गाइस विल टेल मी अगर यहाँ पे एम्बर क्रॉस है तो मतलब क्या, इंडिकेशन खराब। In such a case, the MEL procedure or the operational procedure tells us here, consider this to be unusable. Consider this to be unusable. अच्छा एक बात बताओ, अगर यहाँ पे तुम्हारा ये वाला फ्यूल पार्शली अनयूजेबल है तो तुम्हारे ये वाला फ्यूल ऑन बोर्ड का इंडिकेशन भी पार्शली अनयूजेबल होगा, तो यहाँ पे आएगा हाफ बॉक्स एम्बर, ऐसा आएगा। ठीक है, अच्छा अगर ये वाला फ्यूल पूरा अनयूजेबल है तो कैसा आएगा, ऐसे आएगा। मान लो ट्रांसफर वाल्व्स जो है वो फेल हो गए तो ये दोनों फॉल्ट है, ये दोनों फ्यूल अनयूजेबल हो गया। सो दिस इज फुल्ली अनयूजेबल और ये पार्शियली अनयूजेबल, ऐसा इंडिकेशन है। गॉट इट, आई विल रिपीट इट फॉर यू। मान लो इफ यू हैव अ ट्रांसफर पंप सिस्टम फॉल्ट, if you have a transfer pump system fault, then these two fuels are completely rendered unusable। तो इसमें फुल बॉक्स एम्बर आएगा और यहाँ पे पार्शियल आएगा, क्योंकि पूरे फ्यूल में से सिर्फ 1400 केजी एम्बर, 1400 केजी आप यूज नहीं कर सकते। गॉट द पॉइंट? आसान है। अगर गलती से फ्लाइट में खुल गया तो कुछ यूँ आ जाएगा, और ये होता भी है। हाँ, कई बार ना सिस्टम में फॉल्ट हो जाता है या फिर एक अंडरफुल सेंसर पे, मान लो आप एक स्टीप टर्न कर रहे हो, फ्यूल इधर उधर स्लॉश आउट हो जाएगा, हो सकता है वो अंडरफुल हो गया एक दो सेकंड के लिए। अगर वो एक दो सेकंड के लिए अंडरफुल हो गया देन इन दैट केसेस यू समटाइम्स सी यार हाँ फ्यूल ट्रांसफर हो गया, इवन दो मेरे इनर टैंक पे, इवन दो मेरे इनर टैंक पे 750 से कम नहीं गया फ्यूल, लेकिन फ्यूल ट्रांसफर हो गया। ओके ओके, लास्टली ये जो आपको टेम्परेचर है, आई मेक इट अ लिटिल क्विक फॉर यू गाइस। ये जो आपका टेम्परेचर है, दिस इज द टेम्परेचर ऑफ द विंग टैंक। ठीक है, व्हाट इज द प्रॉब्लम विद द टेम्परेचर? द टेम्परेचर कैन नॉट फॉल बिलो अ सर्टेन वैल्यू, बिकॉज फिर वैक्सिंग होने लगती है, फ्यूल फ्रीजेस नहीं होता है। फ्यूल इज अ हाइड्रोकार्बन, अगर वो फ्यूल ठंडा हो जाएगा ना तो उसमें वैक्स के क्रिस्टल्स होने लगते हैं। सो आई थिंक बिलो अ सर्टेन टेम्परेचर, आई थिंक इट्स 56 or 43 degrees and minus 56 or minus 43 degrees Celsius, somewhere around that, you can refer to FCOM limitations for this। इनफैक्ट आपके FCOM limitations में इसकी वैल्यू है जो आपको पढ़नी भी है। ठीक है, ओपन FCOM limitations have a look फटाफट। Yes, for the purpose of jet A1 it is minus 43 degrees Celsius and the maximum is 54 degrees Celsius that you can use as fuel। Okay, so that is why the fuel temperature is very much important। ठीक है, एंड इसकी एडवाइजरी भी होती है। एडवाइजरी कब आती है? व्हेन इट गोज अबव 45 डिग्री सेल्सियस एंड व्हेन इट गोज बिलो 40 डिग्री सेल्सियस। व्हेन इज दिस इंपॉर्टेंट फॉर अस? व्हेन यू फ्लाइंग इन कोल्ड वेदर सच एज इन रशिया, such as in Russia, and this when you're flying in places like Dubai and Abu Dhabi, it will go into amber when it crosses 50 degrees Celsius। Okay, what is the limit? 54 and 55 MSN to MSN। Any doubts so far? Any doubts so far?
No.
Is there any portions that we are missing right now? APO हो गया, फ्यूल फ्लो भी हो गया, फ्यूल फ्लो भी हो गया. अगेन अगर यहाँ पे एम्बर आ गया, यू नो बेसिकली क्या करना है, राइट? I want you guys to do something. One last thing, okay? I want you guys to do some last thing. Scroll down, fuel temperature indication पे जाइए. I want everyone to go to the fuel quantity indication on fuel temperature indication. Are you there? Scroll till you find fuel temperature and fuel quantity indication. I want you guys to go and read this entire. Okay, that's all you have to do. Other than that, the refueling thing will be sent to you. The notes will be sent to you. Last thing that I want to teach you: go to Ecam upper display. Controls and indicators. Mein, I want you guys to go to Ecam upper display. Are you all there? Total fuel indication. Total fuel indication. Do you see a few things written? Wing outer tank affected, wing inner tank affected, center tanks affected, all tanks affected. Okay. So when the fuel quantity indicator is in the degraded mode, there is a loss of accuracy. These are the loss of accuracies: 20, 110, 130. And if all tanks are affected, that's the final value. Okay. इसका एक क्वेश्चन एक्चुअली आया हुआ भी है, 390 वाला, मेरे एग्जाम में, जो मुझे नहीं आता था. कोई डाउट? नो डाउट्स?
एंड वन मोर थिंग भैया, वो जो हम फ्यूल पेनल्टीज होता है ना, वो किस कैसे कैलकुलेट करते हैं? वो क्या परफॉर्मेंस अलग पार्ट है कुछ?
One second. Tell me if do you have any doubts other than this. That is the end
नहीं,
of the
इसमें तो
chapter.
नहीं है.
That is the end of the chapter. Now to ask you fuel penalty, ये आपके QRH में रहता है. If the fuel penalty is 1.1, what does this mean? This means you're consuming 10% more fuel. You're consuming 10% more fuel. Do you have your QRH with you? Do you have your QRH with you? I want you to open QRH. QRH में जाओ, ops में. Please go to ops, operational data. Have you gone to operational data in your QRH? Go to use of fuel penalty factor tables. Please go there. Okay, गए आप वहाँ पे. Scroll down all the way till you reach an example. Did you see that example? Go through it. If the fuel penalty, I'm reading the last paragraph. If the fuel penalty factor of hydraulic green system low pressure, that then the fuel penalty factor is 10%. What does this mean? Trip fuel penalty क्या होगी? Have a look. My trip fuel penalty will be fuel on board minus EFOB at destination. तो अब मान लो मेरा हाइड्रोलिक ग्रीन सिस्टम लो प्रेशर आया, मेरे ई कैम पे मेरे को दिख रहा है 7 टन मेरे पास फ्यूल ऑन बोर्ड है, मेरे एमसीडीयू पे मेरे को दिख रहा है आई एम लैंडिंग विथ 3.0 टन, मतलब मेरे को 4 टन ऑन कंज्यूम करना. सो मेरी ट्रिप फ्यूल की पेनल्टी क्या है? फ्यूल ऑन बोर्ड माइनस ई फॉप, इन दोनों का डिफरेंस निकालो आप, क्या आ रहा है? बेसिकली मेरा ट्रिप फ्यूल क्या 4 टन है. मैं हो सकता है मेरा ट्रिप फ्यूल 10 टन हो, मतलब टेक ऑफ के टाइम पे, लेकिन ग्रीन सिस्टम मेरा अभी अभी आया, जस्ट अभी आया. सो व्हाट इज माई फ्यूल पेनल्टी? Fuel penalty will not be on 7 tons. Fuel penalty will only be on trip fuel, 4 tons. Okay, so this is my trip fuel for the destination, for reaching destination. इसमें तुम ऐड कर दो 1.1 multiply by 1.1. ठीक है. So what he is doing is he is multiplying it by 10%. ठीक है. 8% for one more thing. तो अगर दो हैं तो आप 18% करोगे. So 18% means 8 by 100. Tuck, 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 tuck. 8 times 4 is 444, 32, 720 kgs. So 720 kg is my fuel penalty. So this is my penalty. You will add this. So 4720 is my actual required trip fuel. Understood? This is how you use the fuel penalty factor tables. Where do you use it? Where is the information given? Use the fuel penalty factors tables, EQRH or QRH, whichever you use. That is the end of today's class.